Students, it's Dr. McLaughlin. I'm going to take a few minutes to go over the key concepts that are associated with Lesson 1. I've listed them for you, and you can see here we have anatomy, physiology, an understanding of how structure relates to function, homeostasis, hierarchy of organization of the human body, the primary tissues, skin as an organ, and the whole concept of interstitial fluid bathing our body cells. Lots of information. I just want to share with you. I've listed these key concepts so that you can read them over, and as you're going through your reading, your textbook readings, and your online activities, you can be checking these off to say, yeah, these are the key concepts. Even though there's a lot of information that go with them, you're understanding the big picture. The outcomes, when we're done, I'm hoping that you have a grasp of these key concepts. Okay? So, that being said, I'm just going to take a few minutes to talk about one of my favorite concepts, and that's homeostasis. What I want you to do right now is just give me a pause. Then get figure 1 that I put in my presentation. Look at it while I'm talking about it. I'm just going to give it a rough overview. Highlight some areas, because I want you to just kind of stress some ways to think about this. And when I'm done, and you're done reading and doing your activities, your online activities, I want you to actually write this down, read page 341 and 342 to get a little more information. Because what you're going to find is that these key concepts, though they're going to be basically defined at this juncture, they're going to build and build and build, and by the time we're done, we're going to weave these key concepts throughout all of our understanding of physiology, and you're going to use and abuse them. Okay, so right now, what we're going to do, and I actually just want to just give this a little breeze over, is I want you to think of homeostasis as a means of keeping our body, its internal milieu, at keeping the conditions set. Okay, so our cells are not experiencing extremes in body conditions. So set points, we have many of them, and they're listed actually if you look at, let me get this right for you, table 1.2 in your book lists several of the homeostatic set points, like blood pH is 7.4 plus or minus 0.05, your heart rate, another homeostatic set point, approximately 70 beats per minute, and blood glucose level is, on average, 90 milligrams. Think of a weight of glucose, a balance in a chemistry lab, a weight, a physical weight, that much weight, 90 milligrams in every 100 milliliters of whole blood. And by the way, another homeostatic set point is the volume of blood in our body, which is approximately 5.25 liters, or 5,250 milliliters. Okay, units do matter. But just look at this diagram, and I'm going to take a few minutes to go over it with you. Homeostatic set point for blood glucose, 90 milligrams per 100 milliliters. This rectangle in the middle of our diagram, think of it as a seesaw, a teeter-totter, you know, with the fulcrum in the middle, and you go up and down. Okay, what's going to happen when Dr. McLaughlin stops off at Dunkin' Donuts on the way to school and eats 4 jelly donuts and a large coffee with 4 sugars in it? I don't do this, but it's just an example. Okay, number 1, this is what we're going to go up now. We're going up, up, okay? What's going to happen? That her blood homeostatic set point is going to shoot up to about, okay, I'm going to hypothesize here, 120 milligrams of glucose per 100 milliliters of whole blood. That's dangerously high, but it's going to be okay, because the organ that's going to read this and have an effect, it's the effector, on bringing this level back down is the pancreas. And on 341 you can see a picture of the pancreas, and I do want to remind you as you go through these key concepts, one of them is anatomy. You can't do physiology without anatomy, so we're always going to go look at what is the structure that's giving this function. Physiology is the function of, you know, how the body functions to create life. Well, This organ, the pancreas, has special cells in it called beta cells. And what these cells do is they read the concentration of glucose in the blood. And when it gets too high, because we're too high right now, I've got a lot of sugar in me, these cells make inside of them and then secrete to the outside a hormone called insulin. A hormone is a molecule that goes systemic. That means it goes throughout our vasculature, all of the blood. And this insulin tells every cell, because every cell has a receptor for it, to eat it up, take it through its plasma membrane, get inside, and be burned to give our cells energy. Pretty cool, huh? Lots of insulin, all my cells are going to have energy. I'm going to be energized. That's why it's, you have a candy bar, you get a lot of energy. But we have a very smart body. Another organ, the liver, is not only going to take in glucose to make energy, but the liver cells, the hepatocytes, now remember, I'm a cell biologist, so I'm going to talk a lot about cells. The hepatocytes are going to do something extra. They're going to take that extra glucose and they're going to link the glucose monomers, make long polymers of it called glycogen, and store glycogen for when Dr. McLaughlin forgets to eat lunch and her glucose level falls. So let's go down. What's going to happen here with number 2? Okay, that's when Dr. McLaughlin is forgetting to eat lunch. And she's working so hard, which usually just runs around Penn State, Bear Valley all the time. She might not get home till 7, 8 o'clock at night, and her blood glucose level could fall to 70 milligrams per 100 milliliters of whole blood. That's dangerously low, but she's healthy. Not to worry. Her pancreas, again, cells in the pancreas, the specific cells here are the alpha cells. Alpha cells are going to read that this glucose level has fallen. They're going to secrete a second hormone. A second hormone. The point is, we're going to learn a lot of hormones. This hormone is called glucagon. I say it slowly because the way I remember it, glucose is gone. Okay? I'm fallen, and this glucose is gone. This glucagon is going to go systemic. Don't forget that word, great word. I mean, it's going around our vasculature, telling, hey, the liver, to break down the stored glycogen, to release the free glucose monomers into the blood, to bring back my glucose level to its homeostatic set point. You could do this. I challenge you to use the diagram, reinforce that you understand it by reading your chapter, doing the online activity, coming back, going back and forth, and adding content from pages 341 and 342. You will see that you're going to get a little more information about this. For instance, skeletal muscles also store glycogen. And adipose tissue can be stimulated by insulin to convert the glucose into fat. So, just telling you, concepts now might seem preliminary, but they're going to build into a broader picture of how we work. So, I'm going to leave now, because you don't want to hear me talk for too long. Good luck. I'm here to look at your formative assessments, and I'll talk to you later.